This is Algebra 1, lesson 8.1, doing multiplication properties of exponents. We're using properties of exponents to multiply exponential expressions, and we're going to model them in real life problems, beginning on page 450 in your textbooks. First thing is a product of a power property. Anytime you product just means to multiply. Remember, anytime you're multiplying same bases, you add the exponents. So you add. So right here, here's an example. A to the m times a to the n. Notice both of the bases are a. So you add m plus n. Then it just gives you numbers to show you the same thing. 3 to the second times 3 to the seventh. Both of those bases are the same, 3 and 3. So you add 2 plus 7, get 3 to the ninth. That is a product of powers property, or the product of powers. That's when you're multiplying the same bases. When you are raising a power to a power, this is when you multiply the exponents. Multiply the exponents. Here we go. A to the m to the n. Now, it's not multiplying the same bases a and a. You're raising a power to a power. So you multiply m times n. Same thing with 5 squared to the fourth. You multiply instead of adding, since it's a power to a power, you multiply 2 times 4 to get 5 to the eighth. And then a power of a product property says find the power of each factor and multiply. And the example is a times b to the m is a to the m times b to the m. A lot of students like to think of this last one as the distributive property. You can raise a to the m and b to the m. It acts a whole lot like the distributive property. It's not called the distributive property, and if you try to write it as the distributive property, it will be wrong. But logically, it's an easy way to think of it. 2 to the 6th power times 3 to the 6th power. So let's look at example 1 to show the difference in those three properties. 4 to the 3rd times 4 to the 5th. So we got the same basis, 4 and 4. What do we do with the exponents? Multiplication pairs with what with exponents? Addition. 4 to the 3 plus 5. You add the exponents. So you get 4 to the 8th. Simple. Same base, 4 and 4, add 3 plus 5. On the next one, you have the same bases, y. All of them are y. But notice it's not numbers this time. It's a variable y. Same thing. Variables are actually easier with this kind of stuff than numbers are, because you don't have to worry about evaluating it at the very end. You don't get a great big number. We're multiplying the same bases, y, and y. You add the exponents. Again, 4 plus 5 plus 6. 4 and 5 is 9, plus 6 is y to the 15th. And again, you don't have to go further than that. We can come up with a number right here for 4 to the 8th. We can get a great big number right there. We stopped at that point. But y to the 15th, we can't get any further than that. The next one, 6 squared times 6. Now, here's one of those instances where the exponent of the second number is not shown right there. You have to not forget, you have to remember that that 6 is being raised to what power? The first power. So if you have to write it in, then do so. 1. So 6 squared times 6 to the first, where you don't forget to add 2 plus 1. Oh, it's written in at that one. 6 to the 2 plus 1 is 6 to the third. Simple. And then the same thing with variables. Negative 3 times negative 3 to the 7th. Both of the bases are negative 3. Both of the bases are negative 3. Remember what the exponent of the first one is. It's negative 3 to the first power. Same bases, negative 3 and negative 3. Add the exponents. 1 plus 7. Negative 3 to the 1 plus 7 is negative 3 to the 8th. Again, it's not a trick. Multiplying, this is all 4 of these examples right here, A through D. All of them are multiplying the same bases. You add the exponents. Example number 2 is using a power of a power property. The easy way to think of this is raising a power to a power. Now we're not multiplying the same base as 7 here. We're raising a power to a power. So it's not 3 plus 5, it's 3 times 5, or 7 to the 15th, 3 times 5. The other one is x squared to the 5th. Again, it's not 2 plus 5. That's the mistake students make with this. They'll add them when they're supposed to multiply and multiply when they're supposed to add. Multiplying bases means adding powers. Power to a power means multiplying exponents. X to the 2 to the 5th, 2 times 5, x to the 10th. Very simple. The next one says negative 2 to the 4th to the 3rd. Okay, it's a negative, and it's being raised to the 4th and being raised to the 3rd. So that's one of those instances where it's negative 2 to the 4th power to the 3rd power is negative 2 to the 4 times 3, which is negative 2 to the 12th power. Again, very simple. It's not tricky stuff right here. Negative 2 to the 12th. And then the last one says b minus 1 to the 6th to the 4th. So b minus 1 to the 6th to the 4th, b minus 1 still to the 6 times 4. B minus 1 to the 24th power. Again, power to a power means multiply the exponent 6 times 4. Example number 3 is using the power of a product property. 2 times 3 to the 3rd. Order of operations says we can do 2 times 3 and get 6 and raise 6 to the 3rd power. The power of a product property tells you could also give the 3rd power to the 2 and the 3rd power to the 3. So 2 to the 3rd times 3 to the 3rd. 2 to the 3rd, it is 8. 3 to the 3rd is 27. And 8 times 27 is 216. Now with b, it's a little easier to see because it's not two numbers like 2 and 3. It's a number in two different variables, x and y. 9, x, and y. Everything gets the second power. 9 gets the second power, x gets the second power, y gets the second power. So 9 times x is just separating it on that step, times y to the second power. Again, everything gets the second power. So 9 squared is 81. There's nothing you could do with x squared because you don't know what x is. And there's nothing you can do with y squared because you don't know what y is. 9 squared, though, is 81. Negative 3z to the 4th power. Negative 3 is going to get the 4th power, and z is going to get the 4th power. That just separates it right there. Negative 3 to the 4th times z to the 4th. This is an even exponent 4, so a negative times itself 4 times is going to be a positive. 3 times itself 4 times is 81, z to the 4th. That's just simplifying it. And the last one, notice the negative out front of the last one compared to C, the one right above it. It's not negative 4 being raised to the 3rd power. It's only 4 that's getting raised to the 3rd power. 4 and W. So that's just identifying the factors. Negative 4 to the 3rd times W to the 3rd. 4 to the 3rd is 4 times itself 3 times. We know 4 times 4 is 16 times 4 is 64. Then, this is a trick to this one, the negative comes down at the end. Negative 64 W to the 3rd. So that's the 3 properties we're looking at. Multiplying the same bases, add the exponents. Raising a power to a power, multiply the exponents. And using the property that allows us to separate it and raise each factor to the power outside of the parentheses. Here's the checkpoint that follows. Oh, one more. This is all 3 of them together. Example 4, 7w squared z to the 7w squared z to the third squared times z to the fourth. You have to do what's inside parentheses first. You have to take care of that. So that means you have to do what's next to parentheses before you try to do the multiplication of z to the fourth. Everything that therefore is going to get the squared that's inside the parentheses. 7 is going to be squared. W squared is going to be squared. And z to the third is going to be squared. 7 squared. W squared squared. That's how you would read that. Z cubed squared and z to the fourth. So all of those are powers to powers. That means to multiply, not add. 7 squared is 49. W squared squared is w to the fourth. Z cubed squared is z to the sixth. And z to the fourth. So you got 49, w to the fourth, z to the sixth, z to the fourth. The last step, you have the same bases. Notice the last two factors, z to the sixth and z to the fourth. Same bases, z and z. So now you add the exponents. 6 plus 4 to get z to the 10th. 49, w to the fourth, z to the 10th. Then we have some checkpoint problems that follow. Simplify this expression. Negative 4 cubed times negative 4 to the 6th power. So right here you have the same base, negative 4 and negative 4. What do you do with the exponents? You add them. Negative 4 stays negative 4. 3 plus 6 is negative 4 to the 9th power. And we're going to leave it like that because it just tells us to simplify it. We could do negative 4 and multiply it times itself 9 times. We know it's going to be negative at the end since it's an odd exponent. It'll be a great big number. The second one, w to the 10th times w. Again, the same base, w times w. What do you do with the exponents? You add them just like we just did. What you can't forget, though, is there's an exponent that goes with that second w. It's what? 1. That's the one you can't forget. So it becomes w to the 10 plus 1, or w to the 11th. And then number 3 says d to the 4th to the 5th. You have a power to a power. Now we're not adding the exponents. Now you are power to a power means to multiply d to the 4 times 5, or d to the 20th. Again, what students will do where they'll make mistakes with this is they'll mix up adding them and multiplying them. Notice the difference between what's happening in numbers 1 and 2 and what's happening in number 3. We added 1 and 2. We multiplied number 3. Number 4 says 6p squared. Both of those numbers, 6 and p, get squared. 6 gets squared and p gets squared. So 6 squared is 36, p squared. All we can do with that. Negative 2, x, y to the 4th. All three of those things get raised to the 4th power. Negative 2 gets raised to the 4th power. X gets raised to the 4th power. And y gets raised to the 4th power. Negative 2 times negative 2 is positive 4. Times negative 2 is negative 8. Times negative 2 is positive 16. X to the 4th, y to the 4th. And the only reason I evaluated that last one out is because it's easy. Whereas 4 to the 9th from earlier is not quite as easy. Number 6 puts all of it together. You have the first set of parentheses, 2w z squared, all being raised to the 5th power. That means 2 gets raised to the 5th, w gets raised to the 5th, and z squared gets raised to the 5th. Remember, a power to a power means to multiply 2 times 5. On the other one, they're all being raised to the 2nd power. That means w gets raised to the 2nd power and z gets raised to the 2nd power. So let's see what we got to do now. Combine everything we can. 2 to the 5th power. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. So that's 32 right there. W to the 5th. Z to the 2 times 5 is z to the 10th, w squared z squared. Notice I have them the same colors, purple and blue respectively. You can multiply the same bases, w and w. Multiplying the same bases means you add the exponents, w to the 5 plus 2. And you can multiply the same bases, z and z. You add the exponents, z to the 10 plus 2. So don't forget this, 32, w to the 7th, z to the 12th. This is as far as we can go. This is lesson 8.20 and negative exponents, going along with 8.1. We're evaluating powers that have 0 and negative exponents, real simple. And then we're graphing exponential functions. We're not going to fool too much with graphing the functions. Beginning on page 456. First thing we have is a definition. The exponential function is a function of the form y equals a times b to the x, where x is a real number greater than 0, and b is not the number 1. Because if it were 1, it wouldn't matter what we raised it to. It would still be y equals a, because a times 1 would simply be a, no matter whatever it is. So an exponential function is something that has an exponent in it. That's all this is saying. It's like you identify a variable function as having a variable in it. An exponential function has an exponent in it. Okay, a definition of 0 and negative exponents. It's just saying let a be non-zero, so anything but 0, and let n be a positive integer. So it's talking about not a negative for the first one. A non-zero number to the 0 power is 1. So a to the 0 power is 1 when a is not 0. If a is raised to the negative number, then it's the reciprocal. So again, ride the elevator. If it's at the top of the fraction, go down. If it's at the bottom, go up. Simple as that. Here's example number 1. Powers with 0 and negative exponents. 4 to the negative 2 power. Again, elevator. It's not a fraction. Make it 1 by putting it over 1. 4 to the negative 2 goes down. It rides that elevator, and it goes down. 1 stays on top, and it becomes 4 to the positive 2. 1 over 4 to the positive 2 is 1 over 16. Simple as that. Ride the elevator. Or multiply it by the reciprocal if you need to think of it in that form. The other one, 4 to the negative 2 is the reciprocal. That's just what it's saying. It is the reciprocal of 4 squared. So 4 squared would be 16. The reciprocal is 1 over 16. The second one says negative 5 to the 0 power. Anything to the 0 power is 1. No matter what it is, anything to the 0 power is 1. The best explanation I've ever had for this, why something is 1, is this explanation right here. If you look at 4, let's say to the 3rd power, that's the same thing we know as 4 times 4 times 4. Everybody understands that. 4 times 4 times 4. 4 to the 2nd power is the same thing as 4 times 4. There's only 2 of them. 4 to the 1st power is the same thing as 4. So how is 4 to the 0 power 1? How does that make sense? This is how it makes sense. This first one, 4 to the 3rd power, is not just 4 times 4 times 4. It's 4 times 4 times 4 times 1. You don't write it in. You don't think of it that way because anything times 1 is just itself. The second one is not just 4 times 4. It's 4 times 4 times 1. The third one is not just 4 by itself, it's 4 times 1. So anything to the 0 power, there's no 4s, it's just 1. That's the best explanation I've ever gotten at this. Hopefully that makes it make a little bit better sense to you. All you got to remember is that anything to the 0 power is 1, and you'll be straight. Next one says 7 to the negative y. Again, a negative exponent means ride the elevator. There's no fraction, so make it 1 by putting it over 1. 7's being raised to a negative. 7 goes down, since it's at the top, and negative y becomes positive y. So 1 over 7 to the positive y. And again, 7 to the negative y is the reciprocal of 7y when you reverse it or when you flip it. B says 1 over 9. Now, just a few minutes ago when we did powers to powers and we did the properties that went with it, we said that if you had more than one thing in a parentheses, like 2x, y to the third, we said to give all of them the exponent that's outside. When you have a fraction like this, 1 over 9, you do the same thing. 1 gets the negative 1, and 9 gets the negative 1. Since 1 is being raised to a negative 1 and 9 being raised to a negative 1, 1 needs to ride the elevator down, 9 needs to ride the elevator up. Or you could think of it simply as the reciprocal. 1 over 9, when you use the reciprocal, it becomes 9 over 1, which is simply 9. And then E is 0 to the negative 2 power. Again, when anything is raised to a negative exponent, it rides the elevator. If 0 goes from the top of the fraction to the bottom of the fraction, now you got 0 at the bottom. You cannot divide anything by 0. That's why 0 to a negative exponent is undefined. There is no reciprocal for the number 0. You cannot flip it and put 0 at the bottom. That's why for E, it's undefined with no reciprocal. Example number 2 is simplifying exponential expressions. The first one, 7 times 4 to the negative y. You got to do what's inside parentheses first. So instead of doing 7 times 4, you got to do 4 to the negative y. Remember, a negative exponent means it rides the elevator. 4 goes down to the bottom, and it becomes raised to the positive y. So 7 times 1 over 4y is equal to 7 over 4 to the y. I said 4y. It's 4 to the y power. 7 over 4 to the y power. 3 x to the negative fourth, y to the negative fifth. Here is something that students mess up. 3 is not being raised to the negative fourth power here. Only x is being raised to the negative fourth. So only x in this instance is going to go down. And y is being raised to the negative fifth. It's going to go down. 3 is going to stay right where it is. It's not being raised to a negative exponent. So 3 stays where it is, times 1 over x to the fourth, times 1 over y to the fifth. 3 stays at the top, over x to the fourth, y to the fifth. Simple as that. 6d to the negative second power. Both terms, or both things, are being raised to the negative 2. 6 is raised to the negative second power, and d to the negative second power. Both of them are going to ride the elevator down. 6 is going to go down and become 1 over 6 squared, and d is going to go down and become 1 over d squared. So 1 over 36 d squared. And the last one, 1 over c to the negative 2x. Again, ride the elevator. C is being raised to a negative exponent. It's at the bottom. It rides the elevator up to the top, and it becomes c to the negative 2x times, or to the negative 2x to the negative first power. What you have to understand is it rides the elevator. So it's times the negative 1. So simply take this, go up with it, and it becomes c to the positive 2x over 1, which is simply c to the 2x. Again, think of this. All of these steps right here are confusing. Just think of it as the elevator rule, and it's much, much simpler. It's at the bottom. It's raised to a negative. It's got to go to the top, and it becomes positive c to the 2x. Then we have example number 3, evaluating these expressions. 2 to the 4th times 2 to the negative 4th. Multiplying the same basis, 2 and 2. What do you do with the exponents? This is going back to the lesson we did first. What do you do with the, that's right, you add them. You add 4 plus a negative 4. 4 plus a negative 4 is the same thing as 4 minus 4. What is 4 minus 4? It's not a trick. 0. And what is anything to the 0 power? Nope. 1. Anything to the 0 power is 1. Remember, anything to the 0 power, 1. What about 3 to the negative second to the negative second? In this case, you're raising a power to a power. You multiply the exponents. Negative 2 times negative 2. You get 3 to the positive 4th. Negative times a negative is a positive, and 3 to the 4th power is 81. What about 2 to the negative 6? What do you do with a negative exponent? Ride the what? Ride the elevator. It's at the top, so it becomes 1 over 2 to the positive 6, or 1 over 64. Not sure why I wanted you to give you a decimal value right there. 1 over 64. Then we have some checkpoint problems that go with it. They're in the back of your sheet. 2 to the negative 5th. Negative exponent means ride the elevator, like this. 1 over 2 to the 5th power. 2 to the 5th power. 2 times 2, 4. Times 2, 8. Times 2, 16. Times 2, 32. 1 over 32 for that one. 4 to the negative 3rd. Same thing. Ride the elevator. 1 over 4 to the positive 3rd. 4 times itself 3 times. 4 times 4, 16 times 4, 1 over 64. 1 over 7 to the negative 1. Both the 1 and the 7 get the negative 1. So if you think of it that way, it's like distributing 1 to the negative 1 over 7 to the negative 1. Both of them have to ride the elevator. This one has to go down. This one has to go up. And it becomes 7 at the top over 1 at the bottom. Remember, there's no reason to write anything over 1, so it's simply 7. Number 4 says 15 times 1/5 to the negative 1 power. Again, you do exponents. Please excuse my dear Aunt Sally. So before you do the multiplication and division step, you must do the exponent step. That means we have to take care of this first. It's raised to the negative 1. That means this is going down, this is going up. So it becomes 15 times 5, because it's 5 to the first power over 1 to the first power. 5 times 5 is 25. 5 times 1 plus 2 is 75 for that. Number 5 says negative 12 to the 0 power times 1 over 5 to the negative 2. Now, number 5 is a very tricky one. It's only very tricky because negative 12 is not being raised to the 0 power. This is a very, very common mistake. Pay attention. Only 12 is being raised to the 0 power. So that's going to give you the number 1. Then this is going to come down in front of it to give you negative 1. Very, very, very common mistake students make. It would have to be in parentheses to be raised to the 0 power to make it positive 1. The second part is a negative exponent at the bottom. So it needs to ride the elevator to the top. And it becomes times 5 to the second power over 1. There's no reason to write anything over 1. You do exponents next. Negative 1 times 5 squared is 25. And negative 1 times 25 is negative 25. Number 6 has 3 times 3 to the negative third. These are the same bases, 3 and 3. Remember, there's a 1 right here. So you add the exponents first. 3 to the first power plus a negative 3. Remember, plus a negative means minus. So 3 to the 1 minus 3 is 3 to the negative second power. Then it has to ride the elevator from the top to the bottom. It becomes 1 over 3 squared, which is 1 over 9. Anything to the 0 power for the next one is 1. 13 to the 0 power. The reason number 5 was negative 1 is because it wasn't 12 to the 0. It wasn't negative 12 to the 0 power. It was just 12. This one's just 13. So times 0 to the negative 2. Remember, what does a negative exponent tell you to do? Ride the what? Elevator. So this has to go down. And it becomes 1 times something over 0 squared. Remember, doesn't matter how many times you square or raise 0 to an exponent, it's still going to be 0. So you're trying to multiply 1 times 1 over 0. You're trying to multiply something over 0. This is a math no-no to have 0 at the bottom of a fraction. So this whole thing for number 7 is undefined. There is no solution to simplify number 7. Number 8 says 15 to the negative 1 times 15 to the positive 1. Remember, there's a 1 there, even if you don't have it written in. You got to see it. Same basis, 15 and 15. So you have 15 to the negative 1 plus 1. You add the exponents. That gives you 15 to the 0 power. And what is anything to the 0 power? 1. Number 9 says rewrite them with positive exponents. A to the negative 6. Ride the elevator. 1 over A to the positive 6. What is being raised to a negative exponent for number 10? Is it 3 and y, or is it just y? It is just y is being raised to the negative 4. Only that part rides the elevator. Y to the 4th, it becomes positive on top, is over 3. 2x to the negative 2, y to the 3rd. Everything in parentheses gets the 3rd. So 2 to the 3rd, x to the negative 2 times 3 becomes negative 6x, and then y gets the 3rd as well. 2 to the 3rd power is 8, x to the negative 6, y to the 3rd. Again, anything with a negative exponent needs to ride the elevator. Only this needs to go down. 8 stays on top, y to the 3rd stays on top, x to the negative 6 goes down, becomes positive 6.